Welcome to Control System Lectures. You are here because you're interested in learning about the awesome world of control system theory, or perhaps you just clicked here accidentally. Either way, welcome, and I hope you find it useful. This is an educational channel with the goal of explaining topics that can be difficult to grasp in a way that might be a bit more relatable. Of course, no one teaching tool can perfectly transfer information to every person in the exact same way because people have different learning styles. My channel provides one method, which is the way that I like to learn. It combines giving an intuitive explanation of the subject with the least amount of math I can get away with, and with a few cartoons thrown in to reduce the monotony of tons of equations. However, my ultimate goal is just to foster your interest in the subject so that you're motivated to read more on control theory, watch more YouTube videos on it, and in the end, learn way more than I could ever cover in a course like this. With that being said, what follows this video is over 9 hours of information that pertains directly and indirectly to control system theory. So in addition to introducing you to my channel, this video is also an attempt at getting you excited about committing a significant portion of the day to watching my videos and really learn the concepts of control engineering. I think you'll find that gaining an intuitive understanding of how systems work, rather than just a mathematical understanding, will make learning the topic much more enjoyable and rewarding. So I think the question now is, why learn control systems at all? Well, I've already mentioned the awesome world of control system theory, so I've exposed my bias towards the topic. But I think the reason to learn it is that control theory is the glue that stitches together all other engineering fields, and by understanding the fundamentals of controls, it opens up the door for you to understand and solve many different engineering problems, and not just as a controls engineer, but as any engineer. For example, as an electrical engineer, you will need to be able to design switching power regulators, which are in almost every electrical device and rely on feedback, and they can be unstable if designed incorrectly. As a communications engineer, you might be building an automatic gain control circuit that automatically increases the gain in weak signals and decreases it in strong signals. Or as a mechanical engineer, you might be concerned with vibrations and damping in your structure, and you may have to design an isolation system in a motor mount for a system that is sensitive to vibrations. As a civil engineer, you might be building an active or passive damping system for tall buildings in earthquake zones. As an industrial engineer, you could be expected to design robotic assembly lines or tune PID controller gains that are ubiquitous in the industrial robotic applications. Or as an aerospace engineer, you might be asked to solve a problem with aircraft flutter. This is a phenomenon that occurs when there is an interaction between the stiffness of the structure and its aerodynamics. These are just a few ways that control theory can span across multiple engineering disciplines, but it will give you a different perspective on relatively normal activities as well. Like when you set your wine glass down a bit too hard and it rings out at a set frequency, and you begin to imagine the vibrating mode of the wine glass, and as the sound slowly dies out, you envision the amplitude of the vibration getting smaller and smaller as the energy is dissipated through heat and sound. And when you touch a vibrating glass with your finger, you're increasing the damping in the system and causing a faster dissipation of energy as the sound dies out more quickly. Or perhaps you recognize that a vibrating wine glass is essentially the technology behind hemispherical resonating gyroscopes, which are used on some submarines and some satellites for dead reckoning. Dead reckoning is the process of calculating a position by knowing where you started and then advancing that position using measured speeds over time. And as you slowly rotate your vibrating wine glass in your fingers, you imagine the standing wave of the vibrations rotating at a slightly different rate due to Coriolis forces. And then you remember, hey, the Coriolis effect is observed in a rotating coordinate frame, like the Earth, and it's the reason for the rotational direction of storms in the northern and southern hemisphere. And you try to imagine the intensely complicated differential equations that drive the entire weather system on Earth, and wonder if you could approximate any part of them as a low-order ordinary differential equation, so that you could write down a computer simulation that gives basic predictions of global weather patterns. And it's at this point you realize that control system theory is so much more than tuning a PID controller or getting an inverted pendulum to stand upright. It's building models of your system and then simulating it to make predictions. It's understanding the dynamics and how they interact with the rest of the system. It's filtering out noise and rejecting outside disturbances. It's designing or selecting proper sensors and actuators. It's testing your system to ensure it'll perform as expected in an unexpected environment. And ultimately, it's being able to understand your system at the most basic level. Everything I just mentioned is accessible to you right now at some level. You don't need a strong math background to understand that when you place your finger on your wine glass, you're removing energy from the system. You just need to know how that relates to what you want to accomplish and where to go to learn more on the subject. And a good place to start is by watching this course, by asking a bunch of questions and engaging with other students in the discussion and answering their questions, and then seeking out other sources of the same material to get a different perspective. I'm glad you made it to my channel, and I hope you make the journey through all of these videos. In the description of this video, I left a few links describing some of the topics I mentioned here. I'd recommend checking a few of them out and seeing if any of them interest you. Don't forget to subscribe to my channel so you don't miss any future videos, and thanks for watching.